Welcome to Microlecture 35, where we're going to do some naming practice with alkyl halides and alkenes. Alright, so let's practice naming these alkyl halide compounds. The first molecule has a bromine atom on it, and I want to lower the number on the carbon atom that's given to substituents. If I number this way, I get a bromine atom on carbon 2 and I get a methyl on carbon number 4. If I number the opposite way, so I'll use a different color, I get a methyl on carbon 2. So the question then is, which way should we number? Because either way, I have a substituent on carbon 2 and a substituent on carbon 4, no matter what. So we're going to use the alphabet, and so we want carbon number 2 to be a bromo rather than a methyl because B comes before M. So a strange situation which we don't usually encounter when we're naming molecules. All right, so we're going to choose carbon number 2 on for the bromine rather than methyl because B comes before M. And we're going to number the way we did in blue. We're going to have 2 bromo. I'm just going to list out the branches first. We're going to have a 4 methyl. And I can see that with, sorry, that was carbon number 1 there. I can see that with 5 carbons in my parent chain, it's a pentane. So we'll put all that together in a second. But the last thing to notice is that carbon 2 has a stereo center on it, and so I'm going to go ahead and name that stereo configuration as well. So I'm going to put the hydrogen in the back. That's where it already is, which is great. And I'm going to prioritize my groups. Bromine is priority 1. The rest of the molecule with the greater amount of branching is the second priority. The methyl is priority 3. So 1 to 2 to 3 is going in a counterclockwise direction. So this is an S stereo center. And so on carbon 2, I have an S stereo center. And that's going to go in parentheses in the front of the name with a dash after it. Putting everything in alphabetical order then, I have 2S, 2 bromo, 4 methyl, pentane. And remember, we only put dashes between letters and numbers, and everything else is all one word, all lowercase. And I see that I have forgotten a dash. See if I can squeeze it in. The dashes separate all letters from numbers, so it would be -2 -bromo -4 -methyl pentane. Okay. The next molecule is a cyclohexane parent chain, and it has some substituents hanging off of it. I see 2 substituents on one of the carbons, so I'm going to start there because the goal is to lower the numbering. And so I would have 2 1s in my name and then a 3 in the name because I have a substituent on carbon 3. And so I've got 6 carbons in my cyclohexane, and on carbon 1 I've got methyl and a chloro. So I'm going to list it out again. I've got a chloro, I've got a 1 methyl, I've got a 3 ethyl, and the parent is a cyclohexane. I want to incorporate any R and S that I possibly can. I see 2 stereocenters here. On carbon number 1, I have a stereocenter, and so I'm going to figure out whether that's R or S. The interesting thing about this one is that the lowest priority group is actually a methyl, CH3 group, and it's in the back, so that's where we want the lowest priority group to be, so that's good. The chlorine takes priority over everything else, has the highest atomic number, so then we have priority 2 on the side that's more heavily branched, and priority 3. And so 1 to 2 to 3 goes in a clockwise direction, and that is an R stereocenter. I would need to redraw the compound to figure out what the stereo configuration is on the other stereocenter on carbon number 3. So let me go ahead and do that. I'll just flip the molecule over here. So this is a flip. Just turning it around so that I get the lowest priority group in the back. That is the only foolproof way to get your stereo center correct 100% of the time. Alright, so now my ethyl is pointed this way, and I can figure it out. Okay, and so the hydrogen atom is in the back, lowest priority group in the back. I've got priority 1, priority 2, and 3, and 1 to 2 to 3 is going in a clockwise direction, so that would be an R. Alright, so in my sort of list of things to include in my name, then I've now got a 1R stereocenter, and I've got a 3R stereocenter. I want to make sure that I include those in the name. So now I'm ready to write it all out in alphabetical order. So it's going to go in parentheses before everything, 1R, comma 3R, parentheses dash. Chloro comes before everything in the alphabet, so it's going to go 1 chloro, and then 3 ethyl. Let me move my compound out of the way. So 3 ethyl, and then 1 methyl. Some of these names get quite long, so we have a little bit more moving to do. And then cyclohexane is the parent name. So very, very long name for that compound, but there it is. Alright, so we have named both of these compounds for practice. Let's go ahead and name these alkenes while we're at it. More practice naming molecules. Again, we want to include R and S, but we also, if there's a carbon-carbon double bond, want to include E or Z in the name. So we want to always lower the number given to the first carbon atom of the alkene, of the carbon-carbon double bond. So that's going to become priority first and foremost over anything else now. If it's an alkene, the carbon-carbon double bond must be part of the parent, and we want to lower the number given to the first carbon in the carbon-carbon double bond. So that would mean that my parent here would be 1, 2, 3, 4, 5. It's a pentene. Notice I didn't say pentane because it's a carbon-carbon double bond. And so it's not an ane anymore, it's an ene. And I see that I've got a 3 methyl, but I've also got a 4 methyl. And so I've got a 3,4 dimethyl Remember, that's how we group together substituents that are the same. So 3,4-dimethyl pentene. And that's not going to be it, because I have a stereochemical designation I can make here for that carbon-carbon double bond, right? I can say whether it's E or Z. So real quick, if I kind of look down the center of this bond, the isopropyl is high priority and the methyl would be low, and the hydrogen would be low and the methyl would be high. And so our high priority groups are on opposite faces, and so this is an E alkene, and it comes on carbon number 2, right? That's why I say the first carbon in the carbon-carbon double bond is the one that is numbered. And so we have a 2E 3,4-dimethyl pentene. Don't forget that it's an ene now, not an ane. All right, next one, we want the carbon-carbon double bond to be in the parent, all right? Because as soon as we see a multiple bond, it's going to take priority, and it's going to be the parent name. So I'm going to start numbering here. 1, 2, 3, 4, 5. Looks like another pentene. It looks like I have a 2-ethyl on my pentene. And in this particular case, well, I have 2 hydrogen atoms, which prohibits me from being able to designate this double bond as E or Z, right? It's a terminal double bond. It comes at the end of the molecule, so E and Z do not apply to this situation. So that would be the name of the molecule. And the last example here, I've got a cyclopentene as the parent. That's all I have to say about the double bond, right? Because it's understood that I'm going to number both atoms in the carbon-carbon double bond. Okay, I can't just number one of them, right? So that means I can't start here and leave out that other carbon in the carbon-carbon double bond and start numbering around like that. That would be wrong, okay? So we don't want to do that. We want to make sure that we encompass the entire carbon-carbon double bond. And so the best way to lower the numbering of this methyl group and include the carbon-carbon double bond in my numbering is to go like this. And like I said, if you just have one double bond in a ring, it's understood where you're going to place the one. Okay, it's wherever that double bond starts on the first carbon. So for that reason, I don't need to indicate that it's a 1-cyclopentene, but you'll see, sometimes you'll see in IUPAC nomenclature that the 1 is indicated. We can leave it out. And then the other thing that's in this molecule is a 3-methyl. And lastly, we have a stereochemical designation. And so I'm going to go ahead and figure out what that is. The hydrogen is pointed back. And so I've got priority 1, 2, 3, okay, in a counterclockwise direction. So this is priority, or this is an S stereo configuration. And that comes on carbon 3, so this is a 3S, 3-methyl. You can leave the 1 out, cyclopentene.